hybridization. It might be a little bit longer, but only because there's a little bit more examples, so hopefully you can understand a little bit more about hybridization, okay? And why we use it and what's going on with it, okay? So I have two vocabularies for you. Sigma bond. This is the symbol for sigma. It's an O with like a little hat. It's the first bond that's made. There's always a sigma bond, okay, in a bond. A pi bond, which is the symbol for pi, second bond or third bond made. Okay, so there's something else to add to it, just a small little bit. It says created by hybrid orbitals on both of them, or on this one, and then on the sigma bond, the pi bond is created from the leftover p orbitals. Okay. All right, so let's get right into this. So what we're going to look at is going a little bit further. Okay, so a sigma bond kind of looks like it is a simple circle. So there's a sigma bond with simple circles, okay? And then you have the pi bond. I'm going to use pink so you can see it better. The pi bonds are kind of like these dumbbells out here. Okay, they're dumbbells, but it's actually right here. Okay, so those are the pi bonds up here. Okay, so there's the pi bonds. Now, one thing you need to know about sigma bonds is they can rotate. Okay, they can rotate. If you want to try to rotate the pi bonds, you can't, because it will break your sigma bonds. So you don't want to you cannot rotate a pi bond. Okay, and these have like a dumbbell shape to them, a figure 8. Okay, so your first bond is always your sigma bond. Your second and third bonds are always made using a pi bond. So those are like triple and double and triple bonds. These are single bonds. So next to sigma, you can put single, but it's not always a single. It's the first bond made, either in a double bond or a triple bond also. Okay, so just kind of think about all single bonds are sigmas. Double and triple bonds can have a sigma and then have a pi bond or more than one pi bond. Okay, so let's get into it. Let's look at this molecule right here, and let's just start counting sigma and pi bonds. Okay, and we'll label them. And I think I'm going to use pink just so you can see it. Okay, so first thing, we're going to start looking at the first bond made. Well, right here there's only one bond, so this is a sigma. Okay, this is a sigma. Okay, we're going to skip this for right now and come back to it. This is a sigma. Okay, this is a sigma. This is a sigma. There's a sigma. We're going to come back to that triple bond, and this is a sigma. Okay, so all single bonds are definitely sigma bonds. Okay, then we come into our double bonds and our triple bonds. There's always one sigma bond, and then the rest is double bonds. The rest is pi bonds. So there's a sigma bond here, and there's a sigma bond here. Okay, now after that we get a pi bond, and here we have a pi bond and we have a pi bond. Okay, so how many sigma bonds do I have? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this molecule I have 9 sigma bonds. Okay, and I have 3 pi bonds. Okay, how does that happen? Well, I told you the first bond made is a sigma bond. So in this double bond, the first bond that was made is a sigma bond. The bonds after that are made are now the pi bonds. So in this double bond, we have one sigma and one pi. Over here, we have a sigma bond, because that's the first bond made, and then there's a pi bond here in the middle, and a pi bond here. Did I say sigma? I hope I said sigma and then 2 pi bonds. Okay, so how's it going so far? Okay, so you can assume that all single bonds are sigma bonds. Double and triple bonds, the first one is a sigma, the second and third will be a pi bond. Okay, so why is this important? Well, let's look at this next one here. Let's kind of look at why we have to do this. Well, I'm going to show you something in chemistry that we like to do, because this is kind of a chemistry thing, and it's something chemistry here. This little part right here is considered a condensed molecule, and it really looks like this: C and then an H. Okay, So if we look at it, how many sigma bonds do we have here in this little condensed molecule? Well, there's one here and one here. So this is how chemists write their formulas and their structures. They don't do everything out